Hello friends, welcome to this video. So here we are going to discuss about force and acceleration. Okay. So we have already learned about acceleration. So here mainly our focus would be mainly on force. Okay. And this is lecture one of this topic. Why lecture one? Because I am going to discuss this particular topic in multiple lecture videos. So let's learn about force and acceleration. So acceleration, okay, we have already learned about acceleration, okay. What is acceleration? So acceleration is the rate of change of velocity, okay. So how much velocity is changing with time, that is known as acceleration. We have already learned about this in one of our previous videos, okay. So now, have we ever asked ourselves a question? So the question is this. The question is, what causes acceleration? Okay. Is there any agent or is there any factor that can cause an acceleration in a body? Once again, what is acceleration? If the body is changing its velocity, okay, if a body is changing its velocity with time, it is said to have an acceleration. Okay, velocity change with time, velocity change with time, that gives rise to acceleration. Okay, so again, so if we ask ourselves a question, what causes acceleration in a body? Okay, so then the answer to that question would be force causes acceleration in a body. So the answer is acceleration is produced by a force. So now you must have seen these examples, very well-known examples. So when you push a chair or pull a door, or a force is applied, okay. So pushing a chair, so all of us might have pushed a chair or we pulled doors when we have to open a door, okay. So push and pull, they applied here in these two examples are examples of forces, okay. When you push a chair or pull, not only chair, push a table, push a bed, or even if you push your friend, so what we can say? You can say that we are applying a force. Here in this picture, you can see that this person is pushing a door, okay, or pushing something, pushing a like something that can be pushed, okay. Or here this person is pulling a door, okay. So both are examples of forces. So push or pull are types of forces, okay. Simple examples of forces. So now let us learn some more about a force. Okay, consider a ball moving on a table. Okay, so we have a ball. Suppose okay, this is a table. Suppose this is a tabletop. Okay, and a ball is there. Okay, suppose the ball is moving from one direction to another direction. Let us see what happens. If we push it along the direction of motion, its speed will be increased. Okay, so the ball is moving, and what we do, we use our hand to push it. Okay, push it along the direction of motion. Suppose this is the direction of motion of the ball. Okay, so if we push it, so the ball is suppose moving with a given velocity, and if we push it, push means what? Push is a type of force, so its speed will increase. Okay, now if we push the ball opposite to the direction of motion, okay, opposite to the direction of motion means, so yeah, in this direction, opposite direction, this is the direction of motion, suppose left to right, and from right to left, that is the motion opposite to the direction of motion of this ball. In that case, what will happen? Its speed will decrease. Okay, the speed of the ball will decrease. Okay, so you can, a very simple experiment, you can also do it yourself. So along the direction of motion of a force, the speed will increase, and along the in the opposite If you push the ball in the opposite direction of motion, push it in a direction opposite to its motion, so its speed will decrease. So what have we seen in both the cases? Okay, that the speed is changing. Okay, speed changes. Speed is changing with time. Okay. So in the first case, when the ball is moving in the direction of when the force is being applied in the direction of motion, so speed increases, and when the force is being applied in a direction opposite to its motion, its speed decreases. Okay. Now another situation may be observed. The direction of the ball can also be changed for the course of its motion. Okay, suppose okay, let me draw the top view of the table. Okay, here I'm drawing a small figure, top view of the table, and suppose this is the ball. Okay, ball is moving, suppose in this direction. Okay, now in this case, what we have considered, that we have applied force either in this direction along the direction of motion, or in this direction, or this is the direction opposite to its motion. Now, what if we apply a push along this direction? We apply a push along this direction. So what will we observe? We'll observe that this ball will move in this direction. Okay. Or if we apply a force in this direction, or if we push in this direction, the ball will move in this direction. Okay. So this way, by applying a push is nothing but a type of force. By applying a push, we can change the direction of motion of the ball as well. Okay, so the direction of motion of the ball can also be changed. Okay, so what we have seen, speeding up, slowing down, or change in the direction of motion result in acceleration. Okay, so what is acceleration again? The change in velocity with time. So when you change the direction of motion of the ball as shown here, that means its velocity is also changing. So in all the three cases, when the ball is moved, when we push the ball in the direction of motion, when we push it opposite to the direction of motion, and when we uh, push the ball so that its direction is changed. So in all cases, we can get to see an acceleration. Okay. So the pushing is a type of force. Okay. So what we are seeing is that basically a force is being applied. A force is needed to cause an acceleration in the body. Okay. So how can we obtain acceleration in a body, or a body can be set in an acceleration? A body can be set in an acceleration by the application of a force. And in all these three examples that have been given here, what is the force? Force is push. Okay, pushing or push is the force here. Okay. So how can we define force? Okay, in scientifically, or in scientific language. So a force is that agent which causes an acceleration in the body on which it acts. Okay, so a force is an agent which causes an acceleration in the body on which it acts. Okay, force acts on a body, and the body gets an acceleration, or a force acts on a body and the body is set in an acceleration. Okay, so force is that agent. Okay, I hope you remember this definition. I suggest you to pause the video here and see these examples. And I hope you also have understood the definition of force. So let me go to the next slide. So apart from acceleration, so can force do anything else apart from acceleration? Okay, so it can also change the shape of an object. Okay, for example, the shape of a plastic bottle can be changed by squeezing it. Okay, so squeezing here is an example of force. So here I have taken a picture where a person is squeezing a bottle, okay, an empty bottle, and you see the bottle has been squeezed here. Okay, so this is not the original shape of the bottle. So, but by applying by squeezing it, okay, squeezing is also a type of force. So the shape of the bottle, okay, the shape of the plastic bottle has been changed. Okay, so in other words, a force can also change the shape of an object. Okay, as you can see here in this example. So therefore, to summarize, what can a force do? Okay, therefore, what can a force do to summarize? Force can change the speed of an object. Okay, it can increase the speed of an object or it can decrease the speed of an object. It can change the direction of motion. Okay, force can also change the direction of motion of an object that we have seen in the case of the ball. Okay, and it can also change the shape of a body. Okay, like in this example, the shape of this plastic bottle has been changed. Okay, so by squeezing also the force, the plastic bottle has become more compressed. Okay, so its shape has been changed. Okay. Now, a resultant or net force. Okay, so what do we understand by resultant or net force? Okay, so let us check it. So many forces may act simultaneously on a body. For example, several people pushing an almirah to change its position. Okay, the addition of all the forces may be obtained as a single force. Okay, this produces an acceleration. So, okay, let me just, so suppose there is an almirah, okay? There is a heavy almirah. So there are several people here, okay? So one person, to the second person, okay? So all the people are, what they are doing, they are pushing, okay? So I could not draw them together, but I hope you understood. So maybe four people. Let me consider four people. Total 4 people are pushing this almirah to change its position. Okay. So what is going on here? So pushing it. Okay, they are pushing it. That means uh, each person is exerting a force on the almirah. Therefore, 4 people. So this almirah itself will experience the force applied by 4 different people. Okay, several people pushing an almirah to change its position. Since the almirah is heavy, so more force will be required to change its position. Okay, if the almirah is here, maybe later it will move here. Okay. After a while, maybe after a few seconds, the almirah will move here. Maybe the almirah will move by suppose 2 meters. Okay. So, so in this case, what we have seen that all the forces may be added. Okay, addition of all the forces may be added as a single force. Okay, so 4 people are here; they are pushing the almirah. So force exerted by each person can be added, and we can get a net force. Okay, total force, or that is also called as the resultant force. Okay. So what is the definition of a resultant force? You can see here, if a single force is acting on a body and produces the same acceleration as produced by a number of forces, then single force is called the resultant or net force. Okay, a single force acting on a body produces the same acceleration as produced by number of forces. Okay, so here in this case, let me just name the forces as F1, F2, F3, F4. Okay, so F1 is the force exerted by the first person, F2 is the force exerted by the second person, and so on, and F4 is the force exerted by the fourth person. Okay, and let us consider that the net force is equal to F. Okay, so if the force exerted, a force acting on a body produces the same acceleration, this is the force which is acting on this almirah, suppose. Okay, acting on the body produces the same acceleration as produced by a number of forces. Okay, here the number of forces are this F1, F2, F3 forces, total 4 number of forces. Then the single force, this single force is called the net force or the resultant force. Okay, so In this example, capital F is the net force, and this net force is the result of four different forces: F1 plus F2 plus F3 plus F4. Okay, F1 being the force due to the first person, and so on. Okay, so I hope this you understood this concept. So four people pushing the same almirah, and some acceleration is being produced. There is a displacement. There is a change in position of this object, heavy object, almirah, and the summation of all the forces can be assumed to be equal to a force which is called the resultant or the net force. Okay, so balanced force. Okay, also another interesting concept. If a set of forces act on a body, okay, if a set of forces act on a body and produces no acceleration in it, the forces are said to be balanced. Okay, so balanced means what? One force is balanced by another force. Suppose, okay, let me give this example, then you would understand this concept better. So here there is a box. Okay, there is a box and two people, they are pushing the box from two different ends. So this person is pushing the box from the left side, and this person is pushing the box from the right side. So these are the magnitudes of the forces. Okay, the first force exerted by the first person, and this is the force exerted by the second person. So these two forces would balance each other. Okay, the force exerted by this person, okay, if we consider the force to be F1, and then the force exerted by the second person, that may be assumed to be F2. Okay, so when F1 is equal to F2 and the forces are being applied from opposite directions, then this box would not move at all. We would see no acceleration in it. Okay? So the box would remain in its own position. It will not move. Okay, and the direction of the box is not, the box is not moving. Okay, two persons are pushing the same box from two opposite direction, and the box is not moving. Okay, so here what is happening? The force F1 is equal to the force F2, and they act on a body in such a way that the body or the box itself is not moving. And in such a case, these two forces are said to be balanced forces. Okay, they are said to be balanced forces. Okay, I mean, one force is balancing the other. Now, if two forces balance each other, then what we understand? If we say that two forces balance each other, then we understand that they must be equal in magnitude and opposite in direction. Okay? Of course, F1 and F2 are equal in magnitude, but they have to be opposite in direction. Like in this example, these two forces are opposite to one another. This person is applying the force from left to right, and this person is applying the force from right to left. Okay, both forces are equal in magnitude, so the box is not moving at all. So unbalanced force. What is an unbalanced force? If you have understood the definition of balanced force, so I hope it will be very easy for you to understand the definition of an unbalanced force. If a set of forces acting on a body produce a non-zero acceleration, okay, the forces are said to be unbalanced. Okay, so see, this is one person here, and there are two people here. Okay, so they are pulling a rope. Okay, so these two people are pulling a rope towards their side, and this single person is pulling the rope towards his side. Okay, since there are two people here, so the force applied by them on the rope will be greater. Okay, force means here the force is nothing but pulling. Okay, so you can see the directions of the force. So basically they are trying to pull the rope towards their direction. Okay, these two people pulling in towards their direction, and this single person is pulling it towards his direction. So since there are two people here, and you can see this arrow is bigger than this black arrow, so that means the force applied by these two people will be greater than the force applied by the single person. So what will happen? So the, the pull towards this side would be greater. Okay. That means there would be a non-zero acceleration. Non-zero acceleration. The acceleration on this rope would be towards this side, these sides, from left to right. While acceleration is be from left to right, because the force acting from left to right due to these two people will be greater than the force acting from right to left due to the single person. So the net acceleration would be in this direction, okay, in the direction of this arrow. And since there would be some net acceleration, there would be some positive value of acceleration, so the acceleration would be non-zero. Okay, therefore the force exerted by two people on the rope is greater than the one by the single person on the left. Okay, so such forces are known as unbalanced forces. Okay, if a set of forces acting on a body produce non-zero acceleration, okay, this is non-zero acceleration, so such forces are known as unbalanced forces. So friends, I am going to stop here for now, and we'll discuss the rest of the things in another video. So I hope you have understood the concepts discussed in this video, and if you have any comments and suggestions, please post your comments in the comment box, and see you in the next video. Thank you very much.